Hot mic. All right, hey everybody, thanks for coming out. This is OKC Ruby Group. My name is Jeremy Green, I'm one of the organizers. This is Paul Dawson, he's also one of the organizers. And today we're doing lightning talks, and I'm going to kick it off with talk about TracePoint. It's for helping you kind of spy on what's happening with your Ruby programs. So what is TracePoint? Well, first of all, it's part of Ruby core, which is convenient. It's not an extra gem. You don't have to install anything. It's just part of the core language. It's always available in pretty much any environment that you can run Ruby. And it allows you to listen for different types of code execution events. And what that means is you can, for instance, register to be notified anytime that an exception is raised. And this is outside of the normal code path. It's not like, saying that you're going to rescue an exception. It's just, let me know when an exception happens. And finally, it's similar to kernel set trace func. And if you're anything at all like me, this last point means nothing. Like, I had no idea what that meant. It's just part of the documentation. And from what I understand, TracePoint is kind of a nicer object-oriented wrapper around this lower level function, which I don't know how to use. So here's a real quick example usage. Like I mentioned, you might want to listen for any exception that's ever raised anywhere within your program. And so you do that something like this. You would create a new TracePoint, and the raise symbol that's in there is telling it that you're interested in any raised exceptions. And then you get a block where when the event happens, you're going to be passed in a TracePoint object that then tells you a little bit of information about the event that's happened. And in this case, we could print out the line number, the event, what type of event it is, and what the exception that was raised is. And so then the next step to actually use this tracer, you have to call trace.enable. And so that means that from that point on, after you've called enable, anytime that an exception is raised, this block that was passed to tracepoint.new will be called. So then if you wanted to test it, you could do something like this, divide 0 by 0. And then the output that you would see there is the output of this block from up above, where we're outputting the line number, the type of error that we got, and the type of the event. And then at the end, you would call trace disable to turn off tracing. Tracing event execution is pretty resource intensive, especially if you register for all of the events. And so you'll very often only want to really trace just a small portion of your code, like what happens around this particular method execution. And so enabling and disabling is pretty important if you want to get sane results and not just be flooded with a whole bunch of stuff that you maybe don't care about and aren't really trying to dig into. So why is this useful and how would you use it? So let's say that you had a function that looks like this somewhere in your code. You're trying to take some data and trying to report it to flakyreportsrus.com. And one of the features of Flaky Reports R Us is that their service is just flaky. You can't really depend on it. It fails a lot of the time when you try to call and send them something. And this particular function was written kind of poorly in that it rescues any error that is ever raised and just throws it away. It doesn't do anything, just swallows it, makes it look like no error ever happened. And so if you're seeing weird non-deterministic problems and you can't figure out where they're coming from, it could be because of this. It could be because this error is getting raised and then swallowed and not handled correctly. So there's nothing to bubble up to actually let you know that an error happened. You just might say, look, we called report data to Flaky Reports R Us, but they didn't get the data, so what happened? And if this particular function lived in your own code base, that might be one thing. You might be able to come across this as part of your debugging, and you might find it and see it and go, oh, look, we're not actually handling that error. But imagine that this function exists in the flaky reports gem and is not part of your code base and is not something that you'd look at on a day-to-day basis. For you to find that this error is being raised but not properly handled, you'd have to open up the source to the flaky reports gem and start digging into, vendor code, basically, third-party code that's not part of your code base to figure out what's going on. And that can be tough, and it might not have occurred to you that that's the problem that you need to be looking for. So you might be able to debug something like this by doing this. Let's say that you're reporting to flaky reports RS in the context of a controller action. So you might set up a before action or an around action to trace exceptions. And this is exactly the same trace point that we looked at in the very first example. We're basically just saying, hey, anytime that an exception is raised, let's log that. No matter how it's handled, no matter who raised it, let's just log that and make it visible so that we can see that an exception happened. That might help you realize that, okay, on the times that it fails and flaky reports isn't getting the data, we can see that this exception is being raised. And that might then finally point you to the source of the problem, and you can maybe, submit a PR upstream to flaky reports and ask them to fix their gems so that it actually bubbles the error and gives you a chance to handle it. So what types of events can you listen for? There are a lot of them. Like we already talked about, you can listen for raise events anytime an exception is raised. The next one is kind of crazy, line. This literally lets you know about every single line of code that's executed. So if you're trying to trace, execution through your program and you're not sure how you end up at different methods, you can literally tell it, all right, print out every single line of code that you execute between enable and disable. And that gives you a real clean, readable way to see how you're stepping through all this. You can do the same thing with the debugger if you want, but if you're looking for particular patterns and you know that you get to a certain place and then aren't sure what happens after that, this gives you a quick way to scan it. You can see, if you're getting stuck in a loop and you're seeing the same lines over and over, it would make it easy to see that. Easy to spot all kinds of patterns that might be harder to spot if you're just stepping through in a debugger. Class will let you be notified anytime that a class or module is defined. End is anytime that it gets to the end statement of a defined class or module. Call is pretty helpful because that lets you log every single time that a new method is called. So this, instead of showing you every single line of code that you execute, just shows you every time that you step into a new method. And return is every time that you return something from a method, whether it actually explicitly returns anything or not. It's just basically, okay, this is the end of the method call. Call and creturn are much like call and return, but they show you when you step into native C code instead of into and out of Ruby code. Call and return are similar to method call and return, except they're for blocks. So if you have a block handler in a loop, or something that is going to yield to a block and it's not a named function, call and return will show you those instances. And then thread begin and end will let you, will notify you anytime a new thread is started or closed. So here's a real-world example of how I used TracePoint recently to help me get my head around some complex code. At one of my clients, there is a controller that is very complex that we have started trying to refactor, and the first part of trying to refactor it is, well, let's understand what it does. And this code, there's so much code there that it's really hard to just read the code and understand what it does and the path that it takes through execution. It's just one controller. There are 91 actions or methods in this controller and 1,600 lines. It's big and hairy and complex. And trying to read it and trace how you get through it is really painful. And I mean, it's just hard to hold that much information in your head at one time to understand how you get from here to there. So I use TracePoint to trace method calls and generate something kind of like this to show you very explicitly on this one call through this controller, these are all of the different methods that got called and the order that they got called in. This is only a little slice of this graph. The whole thing actually looks like this. You can see up in the kind of top left, that's the entry point to the whole, to the main action in the controller. And then everything else, every other bubble is a method of that controller that was called in the servicing of that one web request. So what's the code for that look like? So similar to what we did earlier, there's an around action called graph method calls. And it uses the GraphViz gem to generate the graph. So that's what this first couple of lines are. And then the nodes, this is just a local variable to hold basically the call stack as we step in and out of functions so that we can hook up GraphViz nodes correctly. I registered for the call and return events, so this means that this block gets called anytime that a method is stepped into or out of. And then if the event is a call, we create a new node, a new GraphViz node, hand it the name of the method that we're working with, and then the old node is the last node on the stack. So this is like the method that called the method that we're currently in. And we need to know those two things so that we can draw the connecting line. And so then if we have both a new node and an old node, we tell GraphViz to add an edge, a line connecting those two method calls. And then we stick the new node into our nodes array. And whenever we get a return out of a method, we take the old node is the last node in the gem. That's the method that we're about to step out of. And the previous method, the one before that, is -2 in the array. And if both of those things are there, or if the old method is the same as the method that we're about to step out of, we pop one off of the stack so that our internal representation of where we are in the call stack stays consistent. So then after registering the block for the trace point, it calls trace enable and then yields. So this is where it says, all right, now that we've set up all this stuff before the action happens, just yield through, let the action run, let it do its thing. Anytime a call or return happens, this block above gets invoked and it does its magic. And then after we've yielded and the controller has run to completion, we disable the trace and then output the image that's the graph of all of those calls. This is available in a gist here, and I'll post a link to slides later so that you can find this unreadable URL. And that's it. That's pretty much all I got. Anybody have questions? So Paul asked, how big is the performance penalty? That largely depends on how many events you register for and what you're doing with those events as they come through. If you register for every line and are trying to build GraphViz nodes for every line, things are just gonna slow to a crawl because the overhead of building those GraphViz nodes is gonna be way higher than the actual execution time of those lines. And so for every line that should take 10 milliseconds to execute, you're going to have 50 or 60 milliseconds worth of building GraphViz nodes. And so things are going to go south real quick. So you have to be kind of judicious on what events you register for. Within the event handler, you can block stuff out. Like I skipped over this. One of the things that you get in the TracePoint is the path of the file that's being executed. And so like in this one, I know that I only care about looking at things that are in the app controllers directory because I don't care about what's happening in the model or any of that stuff. I'm just focused on that one controller. So if you can find ways to, even if an event gets fired and you have to get notified about it, there are ways that you can filter and say, this is an event I don't care about, so I don't need to incur any extra overhead.
So whenever you use TracePoint to catch an error, normally that's going to shut down your program since it's not running.
Mm-hmm.
TracePoint do that. Like, does it change that at all? Like, will the program still exit, or will it kind of rescue it?
So the question is, when you register for a raise event, does that alter the execution of your program? Is it the same as rescuing that raise? And the answer is no, it doesn't. It doesn't alter the execution path of the code at all. It just basically gives you a little sidebar where you can say, okay, I see that this raise has happened, and I can log some data about it, or I could, I suppose you could maybe even try to do some sort of error handling in there, but TracePoint's really more of a debugging tool than it is a code cleanliness tool. Like, I wouldn't recommend having TracePoint stuff deployed to production. You probably don't want to do that. There may be some instances where you do, but it's not at all a substitute for actually rescuing an exception and handling it at the place that you expect that the exception is going to be raised.
Does the handler end up getting events for the handler?
Oh, that's an interesting question. Does the handler end up getting events for the handler? So I think what you're asking is, since this is a block that you pass to TracePoint, if you registered to be notified about bcall and breturn, or line, yeah, will the execution of your TracePoint handler generate new TracePoints? And I don't know. That's a great question. I have no idea what would happen there. I guess yeah, I was going to say a completely wild guess is no, because I think that's going to end up, you could get stuck in a loop where you just can't ever break out, but I honestly don't know and haven't tested it, so I can't say for sure.
I know it's not common practice in Ruby, but what would happen with this if you tried to use a recursive function call?
You mean, so okay, so the question is, what would happen if you use recursive method calls? You mean like inside of the code that you're trying to instrument, not necessarily inside the handler? Yeah. You'll get notified of each recursive call. So if you're doing, let's say, a multiply method in the way of, okay, we're just going to keep adding versions and recursively calling it until the. How would it graph that? I think that would really depend on how you structured this. I think the way that it's structured right now, I think you would just see a deep chain of, multiply, called multiply, called multiply, called multiply, and then you'd see it going back up the chain. Any other questions? All right.